All right, so this is going to be a lesson over writing expressions. So these notes we've already kind of filled out for you. So that way we're not spending so much time of actually writing these out. We can just talk about it. So when we're writing an expression, the first thing that I want you to know is that when we do a expression, an expression does not contain a equals sign. Okay, so sometimes we have different ways the mathematical operations can be stated. So we're going to go ahead and look at some keywords that might help me to decide that when I'm reading a problem that it's going to be an addition type problem. We've got added to, that's duh, right? Added to. Plus, that would tell me that I'm going to be adding. Some would tell me I'm going to add. More than, that will tell me. A couple others that aren't in here that I want to add is increase. Increase also tells me I'm going to be adding. Gain tells me I'm going to be adding. And deposit tells me I'm going to be adding. Those are a couple additional ones. When we get to subtracted, we get the word subtracted from. We get take away, difference, minus, less than, taken from, decrease, withdraw, and loss. Those are some things, some keywords that tell me that my expression is going to be a subtraction expression. Multiplication, we've got times, multiplied by, product, groups of. All those tell me that I'm going to actually, that should, so that I know that it's all one word. Groups of, that tell me that I'm going to be multiplying. Division, divided into, divided by, quotient, divided equally. And then once we get into it, as we write expressions, we're also going to get into writing equations. So if it's going to be equals, it's going to be is, was, were, have. So I might say 5 added to 3 was 8. That word was tells me that it's going to be an equal sign. The same as, have, has, of course, equals. The word equals will tell me that I'm going to write an equal sign. All right, so let's go ahead and get down to, those are just my keywords. So, writing an expression. Verbal statements can be translated to algebraic expressions. Another awesome thing, you're going to go home. Parents ask you today what you learned. You can tell them how to write an algebraic expression. They're going to be like, what? Yep, you're going to blow their minds. It's like deciphering a secret message or translating from one language to another. An expression is a mathematical phrase that contains numbers, variables, and operations. Numbers are numbers. Variables are letters that represent a number, yes. And operations, add, subtract, multiply, divide. It does not contain an equal sign. Super important that we know that an expression does not contain an equal sign. Very, 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 so I'm even going to write that. No equal sign. And I kind of think of it like this. If I were to walk in and I just had a smile on my face, you wouldn't know. It's just an expression. You wouldn't know if I'm smiling because something great happens, happen? Or am I smiling because I'm about to give you a pop quiz? Am I smiling because I am trying to hide the fact that I'm mad? You don't know. I'm just smiling. It's just an expression. Could mean lots of things, right? Okay. So parts of an expression that we're going to see is, so this is a problem that we have right here. 4D minus 9. 4D minus 9. First of all, let's decide, what does that 4 and that D next to each other mean that I'm going to be doing? What operation? Multiplication, right? Side by side like that means 4 times D minus 9. Okay? So let's break this down on what we have. We have our variable, the letter D, right? We have our coefficient. It's a nice, lovely word. Coefficient is just the number that's next to the variable. Okay? We've got our operation, add, subtract, multiply, divide. Our constant, that means that it stands alone. Then we have this right here is my term, and this whole thing is what we call our expression. So the one thing that you have to understand about expressions, and this is something that you have to take out of your brain, just because it's math, it doesn't need to equal anything. We have no idea what 4D minus 9 equals. No idea, right? We don't have to know that. I just need to know that that is an expression. It could simply, if I were to write a word problem, it could say 4 times a number subtracting 9. That's all I'm asking. I'm not having to tell me what that number is. I'm not trying to say, oh, it equals this. I'm just writing an expression. So we're going to look at some examples on that. Okay, we're going to write an algebraic expression to represent the verbal expression. Okay, so we've got 8 more than a number. So I'm going to underline that. What are we going to put in the place of a number? Do we know the number? No. So what do we put? A what? A variable, right? Okay. 8 more than a number. So that more than tells me I'm going to do what operation? Add, subtract, multiply, divide. Add. So that's what I'm going to start with. I know for a fact that I'm going to add. Is everybody with me on that? Okay. Question?
Yes.
Okay. On what?
How do you know it's how do you know it's an expression?
Okay, so we'll get to that in a minute. Right now, all I'm trying to do is decipher. If I were to say 8 more than a number, I don't want words, I want a mathematical problem. So I know more than tells me I'm going to add. So I'm going to start with that, because at least that's a baby step. Now I'm going to do 8 more than a number. 8 more than a number. That means that I'm taking a number and I'm doing 8 more than that, right? So I'm going to do a number, any variable that you want. Me, I'm going to use X. Not for any other reason, but because my brain is programmed to use X as my default. Okay? If you want to use J or R or Q or N, you use whatever variable you want. Me, myself, I'm going to use X. And it's going to be X plus 8. That tells me this is 8 more than X. Does 8 plus X tell me this? Is that the same answer? Yes. We learned yesterday that commutative tells us that X plus 8 and 8 plus X are the same thing, right? That's it. I don't have to worry about figuring out what X is. What is that answer telling me? That's all I need to do, is just write that expression. Okay? All right, so let's look at another example. The difference between a number and 5, difference tells me I'm going to do what? What operation? Subtract. Right? Because if I come up here, difference tells me it's still going to be subtraction. So I know I'm going to start with a subtraction sign. Now I need to decide what number is going to go first, because it really does matter on subtracting the order, right? Correct? So it says the difference between a number and 5. So a number and 5. That's it. There's no, but I don't know what x is. It doesn't matter. We don't need to know what x is. All right, 19 added to a number. What operation am I going to be doing? Adding. And I'm taking 19 and I'm adding it to a number. So it means I started with a number and I'm adding 18. Oh, sorry. I don't even know where I keep saying 18 at. 19, sorry. My bad. Okay. Let's flip this over. All right, so let's read it. 6 less than a number. So 6 less than n. All right, less than tells me I'm going to do what operation? Subtract. Okay, so that's what I'm going to start with. Now, when I read this, 6 less than a number. So the order really does matter when we are subtracting and dividing. So I really have to make sure that I have it in the correct order. So I'm going to think about this. If I gave in a number, and I'm just pulling a number out just for purposes, I'm going to say 10. Let's say that the number is 10. If I were to read that and ask you, what is 6 less than 10? What would you tell me? 4, right? 6 less than 10, right? You would say, oh, okay, I'm going to take 10 and I'm going to subtract 6 from it because it's 6 less than 10, right? So I have to think, I'm going to do n minus 6. It'll come up here in a minute. N minus 6. I know, it'll catch up. It's still recording here. Okay, it's just not wanting to listen to me today. All right, number 5 says the difference of 10 and Q. So I'm going to box 10 and Q. And the word difference tells me I'm going to do what? Subtract. I'm going to subtract. Perfect. Now I have to decide what number is going to go first. Is 10 going to go before Q? Well, because it's just saying, hey, what's the difference of those two? I have to put them in that specific order. 10, the number 10, minus Q. All right, number 6, 19 added to J. So I've got, there we go, it's catching up now. Added to tells me it's going to do what? Addition. And I'm taking J and adding 19 to it. So it's going to be, J plus 19.
But you could do it the other way too.
Okay, that's a good question. Can I do it the other way? Does it matter which order I do it in? Does it matter which order I'm doing it in? It doesn't matter which order I do it in when I'm adding, right? Correct? Okay.
This is the new one.
Okay, so it doesn't matter if I were to put 19 plus J, because in our commutative property that we learned yesterday, that the order doesn't matter when it's adding. It would definitely throw in, the order would matter if it was subtracting or division. So I would take 19 plus J, but I will not take it if it's a subtraction and it's flipped. All right. All right, we're going to continue to work on, I know you're not going to see it, so you're going to have to be listening because it's still recording. It's still going. All right, 14 increased by B. So I'm going to underline or box in 14 or underline it however way you want it, and B. So this one's telling me that I have or it tells me what my variable is going to be, correct? All right, so let's get this written in there. So we've got increase tells me I'm going to do what? I'm going to add, right? And then I'm going to do 14 is increased by B. So this one will be 14 is increased by B. All right, K less 7. K less 7. All right, the word less, what does it tell me I'm going to do? All right. So at least I can make sure I'm getting my right operation. So it says I'm going to subtract. Now I have to decide, because subtraction, the order matters, right? So I have to decide, am I going to be doing K and subtracting 7 or 7 and subtracting K? So it says K less 7. This one's pretty easy. I'm going to do it exactly the order that it's doing. K less 7. K minus 7. Go ahead and do 9, 10, and 11 on your own, and we're going to check those out. I'm going to give you just a few minutes to do 9, 10, and 11. Think about your keywords. What are my keywords? So I've got 12 less than P. 12 less than P. I know it's going to be subtraction. And I'm going to do 12 less than P. So it's going to be P minus 12. Because it's 12 less than whatever my P is. All right, next one is the sum of G and 11. That's pretty easy. Sum tells me it's going to be adding G and 11. Is that what, G and 11? Pretty easy. I'm going to add G and 11. Last one says T is decreased by 3. So decrease tells me it's going to be what? Subtract. So I know that the order matters, so I really have to focus on that. And I'm going to take T and decrease it by 3. So T decreased by 3. T is decreased by 3. All right. Let's talk about how, when we're writing it, these were all just adding and subtracting. So let's talk about multiplication and division. Multiplication is written side by side with a coefficient in front of the variable. So it will look like this. I'm going to have a number and a variable. That huge number is my coefficient, and of course this is my variable. Okay? That means when it's side by side that way, it means that it's going to be multiplying. So you might want to write that down. That when it's side by side like that, it means that you're going to multiply. All right, so we're going to kind of just work through both the multiplication and division. So, so we know that when we multiply, the order doesn't matter. but visually, our number should always go before our variable when we're multiplying. So the first one we have is the product of 9 and n. So that would look like the product of 9 and n. That's going to tell me right there that 9n tells me that I'm going to multiply those two. 9 times n. The next one is q times 12. So we don't write it this way because that looks weird, right? So we have to write it with our coefficient first, which would be 12 times q.
So is your number always going to be the bigger one? Like first, like in
Yes, when you're multiplying, your number will always come right before your variable. And then we've got twice a number. Twice means that what's my coefficient going to be? 2. So it will be 2n. That was not good. It's okay. That's just my stapler for those of you watching. No worries. 16 multiplied by j will be 16 multiplied by j. 16 multiplied by j. All right, so when we go to the dividing matters, right? The order matters how I write it. So this is where it's really going to come in handy, just like when we were whenever we were doing subtraction, we have to really think about what order am I doing. So k divided by tells me I'm going to be doing what? Division. And so I'm taking k and I'm dividing it by 10. So it's going to be k divided by 10. And I can write this in a couple of different ways. K divided by 10. I can also write it in like a fraction looking. K over 10. Because we know that k over 10 means k divided by 10. Correct? So we can write it either way. Next one is the quotient of x and 6. Quotient tells me I'm going to divide. So it's x divided by 6. Or x divided by 6. Nine divided by c. That's pretty easy. 9 divided by c. And then our last one, the quotient of 4 and q. So 4 and q. So all right. So we're going to go ahead and end for this lesson right now. We're going to end on that. Sorry, y'all didn't see that up there. There we go. I'm going to end for this lesson right now, and then I'm going to do another lesson on equation.